My name is Epson Gavi, PhD in Engineering and Applied Sciences. My topic for today is on troubleshooting electrolytic and galvanic corrosion in modern vehicles. Yeah, I'm going to discuss about what exactly is electrolytic corrosion. But before I go into detail about electrolytic corrosion, I have to define what exactly is corrosion. Corrosion is the degradation of the materials due to chemical action or due to environmental action. And now, to be more precise, I'm going to define what exactly is electrolytic corrosion. It is a process of accelerated corrosion. In this process, a metallic surface is continuously corroded by other metal it is in contact with due to an electrolyte and the flow of electrical current between the two metals caused from an external source. In this case, the external source is the battery. Again, electrolytic corrosion seems to be a common problem on most modern vehicles that have aluminum heater cores and radiators. This is based on the experience that I have as someone who was working in automobile for some years. I've seen that there's so much corrosion that is occurring on a lot of heater cores. You replace them, and after a short period of time, only to replace them again. Um, Electrolytic corrosion is often confused with galvanic corrosion. I'm going to differentiate between the two. Galvanic corrosion is driven by the difference in corrosion potential between two metals. In other words, galvanic corrosion requires an external, sorry, in other words, galvanic corrosion requires two dissimilar metals inside an electrolyte to generate voltage. Whereas in electrolytic corrosion, you require an external source of EMF, in our case a battery, connected to two different metals inside an electrolyte. In this case, our electrolyte will be the coolant. Here we have a diagram of an electrolytic cell. An electrolytic cell is an external battery source, as what is shown on the diagram. It converts electrical energy into chemical energy. And the redox reaction is a non-spontaneous process, since the electrical energy is to be supplied to initiate this reaction. And both the electrodes are in the same container as we see. And we need to have a molten electrolyte. But again here, the anode is the positive and the cathode is the negative. So this is the reverse to the galvanic cell. However, the anode is still the oxidation and the cathode is still the reduction. The external battery supplies the electrons and then they enter through the cathode and come out through the anode. This diagram shows a good example of a galvanic cell. Galvanic activity is created by two dissimilar metals in contact with a liquid. In our case, it will be the coolant. A galvanic cell converts chemical energy into electrical energy. And here the redox reaction is a spontaneous reaction. The anode is more reactive metal and the cathode is less reactive metal. As we know, inside a car, cars have dissimilar metals. You find sometimes an aluminum block is joined by iron balls, so cars have a lot of dissimilar metals. connected together. Automotive cooling system. It's important that we know what exactly is the cooling system of any automobile. The engine cooling system has an effect on your vehicle's engine longevity and overall dependability. The basic parts of the cooling system are responsible for moving heat from the engine and automatic transmission and making sure heat is thrown out outside the car. So if the cooling system is made up of coolant that is dirty or that is rusty, then the engine is not going to last. A rust engine is not efficient. So it is important that we keep the engine from rusting. Parts of the engine cooling system. The engine cooling system is comprised of course, of the coolant. The coolant is made up of the antifreeze and the water, distilled water to be more precise. It's mixed in the ratio of 50 to 50. It has the cooling fan, the cooling reservoir, the heater core, the hoses, the radiator, the thermostat, and the water pump. The water pump is one of the most important part of the cooling system, since it's responsible for creating pressure and the force so that the water can be transmitted. And the thermostat is there to ensure that the water reaches the optimum temperature, because there's a normal optimum temperature that the cooling system has to operate around 220 to 200 and between 220 to 250 degrees centigrade. Sorry, degrees Fahrenheit. So the thermostat, once you reach that particular temperature, is going to open and it allows the water to cool down. This is the diagram that shows the car cooling system. It is the high side and the low side. The high side is represented by the red and the low side is represented by the blue. The high side is the side where the coolant is hot. It's coming straight from the engine and the coolant is extremely hot. And then the low side, the coolant is cooler because it has been cooled by the radiator. Some of the heat has been thrown out by the radiator and the cooling fan. So as we know, it's made up of the radiator, expansion tank, the heater, the thermostat, and the water pump. It's really important to know what exactly is the coolant. The coolant is a mixture of the water, which is the distilled water. We recommend distilled water. 50%, we need 50% distilled water and 50% ethylene glycol and some additives or inhibitors that prevents corrosion. So now the question is, the inhibitors are put inside the coolant, and then why is that the corrosion occurs is mostly seen on the radiator, the heater, and the water pump? So this is what we are going to address as we go further into this discussion. What is the purpose of the coolant? The coolant is a heat exchange medium. It's there to transfer heat from the engine to the radiator. And moreover, it protects the engine and the cooling system from rust and corrosion. It also protects freezing in cold climate. So this is one of the primary importance of the coolant, is to stop freezing, because we know that during freezing the water expands. In other words, the volume of the water increases. So this might cause the bursting of the tubes and so forth. So this is the primary purpose of the coolant, is to help to protect um, the components of the engine like pipes from bursting because of freezing, and it also stops corrosion because there are additives put inside of it. Now we are addressing the symptoms of cooling system electrolysis corrosion. Number one is the failure of the heater core, and one of the things that happens is when you replace it, it you see it failing again before a year or less. And another symptom is the coolant leaking from the heater core. Once the coolant starts leaking from the heater core, it leaves some drips, wet spots, or stains on the carpet of the passenger. And another prominent sign, is the sweet smell. Once you turn on the AC and you feel the sweet smell. We are still discussing on the symptoms of electrolysis corrosion. Uh, Radiator hose failures or radiator failure. You find blockages on the radiator and extreme rusting. Coolant leaks at the intake manifold gasket connections. Overheating, and overheating is a very big problem because it can cause the head gasket to blow out, and this will lead to some of the coolant getting into the combustion chamber, and this will cause the destruction of the engine. You have to repeatedly add the coolant each and every time. This is the diagram that shows a radiator. Um, Showing the red arrow shows the points where there is leakages, and as you can see, these points, they are blockages that results from electrolysis corrosion. You should understand that once you have electrolysis corrosion, it leads to some metallic ions to be transmitted within the coolant. So this metallic ion, they will be transported, and they will end up having a chemical reaction with aluminium, and they can also cause blockage, leading to the failure of the radiator. Causes of cooling system electrolysis or galvanic corrosion. Point number one, worn out coolant. Over time, the corrosion inhibitors in every type of coolant, they wear out. I can say mostly after between 2 to 3 years, or after traveling for between 30,000 to 50,000, some to 70,000 miles. So the inhibitors inside every coolant will fail. Once your coolant turns from alkaline to acidic, electrolysis starts to eat away the metal surfaces inside your cooling system. Sooner or later, your cooling system will start to leak. The current that causes electrolytic action usually emanates from poorly installed electrical circuit. That current, we call it stray current, and there are various reasons that I'm going to outline that causes that stray current. One of the reasons is bad ground. We are still on the causes of electrolysis or galvanic corrosion. Another point is short to ground, short to voltage, current leak due to damp condition, stray electrical currents in the coolant, wrong mixture and type. You are supposed to use recommended by the manufacturer, recommended coolant by the manufacturer. Mixing antifreeze with tap water instead of distilled water. How to check electrolysis or galvanic corrosion. I'm going to outline the steps necessary to check electrolysis or galvanic corrosion. Set the voltmeter to DC volts. The reason why we set to DC volts is because an electrolysis cell or galvanic cell produces DC voltage. Point number 2, connect the black lead, which is the negative, to the engine ground. Every car, every automobile has 3 main sources of ground: the engine block, the thin sheet metal, and the battery. Actually, the battery is the best ground. Place the red meter, which is the positive. Place the red meter lead into the coolant. Now read the voltmeter reading. Voltage above 0.5 volts indicates excessive galvanic activity. If you have that reading of 0.5, then that is what it implies. It means you have excessive galvanic activity. And in those conditions, you are supposed to drain and flush the coolant out and put the new coolant. A good voltage reading should be less than 0.2 volts. Testing excessive electrolysis, we're going to do the same thing that we did on the previous slide. The first thing, we're going to turn on the digital multimeter to DC volts. Connect the black lead to the ground. In my case, I favor the engine block, and then connect the red probe, which is the positive terminal. You put it inside the coolant. Now start the engine. The engine has to be running, and turn on or off all accessories. When I say accessories, I mean things like the radio, the fan, the headlights, etc. They can be either on or off, but the engine has to be running, because when the engine running, that's where we have the electric current flowing around. Read the voltmeter. Reading higher than 0.5 volts indicates excessive electrolysis. Check all ground connections, and one of the most likely problem is the short to voltage. That is the most likely problem for that. A good voltmeter reading should read less than 0.3 volts. The diagram shows the way of measuring galvanic corrosion or electrolysis corrosion. The first step is to set the digital multimeter to DC volts, and place the red probe, which is the positive, right inside the coolant, and the black probe is placed on a good ground. This could be a sheet metal, or it could be an engine block, or it could be the battery. In this case, it is the battery. And take the voltage reading. This diagram is to show the ways of measuring or determining whether the coolant is corrosive or not. We know that acidic coolant is a catalyst to corrosion inside the cooling system of any automobile. You connect the black probe to the battery, to the negative terminal of the battery, and the red probe is put inside the coolant as shown on the diagram. And check the reading. Disconnect the black probe from the battery and connect it elsewhere. If the reading is too high, then it shows that the coolant is acidic, and then you have to flush out the coolant. I've already illustrated on methods of measuring galvanic corrosion or electrolysis corrosion. Now I want to explain ways of testing for coolant, if the coolant is good or if the coolant is bad. Since the coolant is the primary component of the cooling system of any automobile. So these are the ways of testing coolant. Number one is visual inspection. By just checking, you can see whether the coolant is good or bad. And number two, you can do the pH testing. You can find a small paper for the pH, and you dip it inside the coolant, and a good coolant should be between 7.5 to 10.5. But the reading of 7.5 to 8.5 is usually for the used coolant. Check the coolant voltage, we've already discussed about it. Hydrometer testing. Hydrometer testing measures the density of the coolant. Higher density implies that you have high concentration of antifreeze, and it's not good because the recommended mixture should be 50 to 50. Refractometer testing is a way of measuring the refractive index of the coolant. When you say the refractive index, we talk about the bending. If you allow the light to pass through the coolant, how much does it bend? So you compare the used coolant to the pure coolant, and you see how much does it deviate.